This is for class 12. For class 12. Class 12. I have selected this topic because in your NCERT textbook, this has been this statement has been proved very beautifully. You can't imagine how beautifully they have proved this statement. The statement is that I have made a the statement is that you all know about it, that the minimum cutoff frequency below which there is no photoelectric emission. That is the statement is that you have proved that your statement is that minimum cutoff frequency minimum cut off frequency minimum cutoff frequency below which there is no photoelectric current. Photoelectric emission. Photoelectric emission. This statement, they have proved it, but it has been proved so beautifully you can't imagine. It has been proved very, you can't imagine how slowly and in a step-by-step pattern they proved this statement. So first of all, what is done in your book, that it first of all it showed you a graph that is this is collector potential and here this is your retarding potential. Here this is your retarding potential. This is your collector plate potential. And here this is your retarding potential. Here this is your retarding potential in this direction. Retarding potential. And then this is photoelectric current. Here it is taken, they have taken as photoelectric current. Photoelectric current. Yeah. In y-axis, in x-axis, this is your origin, and along x-axis in positive direction is collector plate potential. Collector plate potential, you know about it, that your vacuum tube here, there is the collector plate, and here the light is strikes the plate. From here electrons emits and it moves towards the collector plate. So you know all this about it, but see how they have proved it in your book. So here what they have done, that they have taken different frequencies but of same intensity. They have taken different frequencies and they found the graph, it was like this. They took different frequencies. They took different frequencies and your saturation current was constant here. Your saturation was constant here. This is the saturation was constant here. Saturation is constant here. Now they took different frequencies. So let this be frequency 3, frequency 2, frequency 1, and they got different stopping potential. Let this be V0 1, V0 2, V0 3. And from this, what they found that as the frequency increases, the stopping potential also increases towards the negative direction. As the frequency increases, your stopping potential also increases in the negative direction. That means the result is like this: your frequency V3 greater than V2 greater than V1, and your stopping potential is the same manner. Here you see. This is the result they got. So from this, what conclusion they got? That means your frequency is proportional to your stopping potential. Greater the frequency, greater is the stopping potential towards the negative direction. That means they got a relation. What is the relation? They got a relation between the frequency and stopping potential. They got a relation between frequency and stopping potential. This is the relation they got. So when it was tested in different metals, they got, here you see the graph here, this is your stopping potential. Is in your y-axis and your frequency is in x-axis. So say some for metal A, they got a straight line. So here we see that as the frequency increases, your stopping potential also increases. So from this graph they concluded this thing. They tested in a metal, and in a metal they found this. It was a straight line. That means as the frequency increases, your stopping potential also increases. Now here, one very important point is that at this point, your stopping potential is 0. V0, stopping potential is 0. At this point, your stopping potential is 0. Stopping potential is 0. That means at some frequency here, some frequency say dash, your stopping potential is 0 at this point. So this gave a very important decision. That means at this frequency your stopping potential is 0. That means at this frequency your kinetic energy of the electron is 0. That means at this frequency your kinetic energy of the electron is 0. That means what does this mean? This is 0. So what does this mean? This means that the electron will just move out of the metal, just move. So your velocity is 0. So your kinetic energy is 0. Just it will move out of the plate. So see how interesting it is. How they have proved in a systematic manner that at this frequency, that means your stopping potential is 0. That means your kinetic energy is 0. That means the electron has just moved out of the plate and it is lying there. Because there at that stage your velocity is 0. So this frequency they call it as a cutoff frequency. This frequency they call it as cutoff frequency. Frequency. Now, again, one more conclusion from this graph, that what we have got here is, greater the frequency, greater is the stopping potential. Greater the frequency, greater is the stopping potential. That means, what does this mean? The more the stopping potential, that means the electrons have more kinetic energy. More the stopping potential, that means that concludes that the electron has more kinetic energy. So, when the kinetic energy is 0, that means the electron has just moved from the metal surface. So, this is the frequency where the electron has just moved from the metal surface. And below this frequency, there will be no photoelectric current. Below this cutoff frequency, there will be no, because below this, there will be no photoelectric current. So see how beautifully they have proved this statement. How beautifully they have proved this statement. So they have also written that the energy of the emitted electrons depends on the frequency of the incident radiation. The conclusions, what are the conclusions they have got? So what are the conclusions they have got? Here you see the conclusions they have got here. First is that the energy of the emitted electrons depends on the frequency of incident radiation. And first, now second conclusion is that stopping potential is more negative for higher frequencies of incident radiation. And the third, it implies that greater the frequency of incident light, greater is the maximum kinetic energy of the photoelectrons. We need greater retarding potential to stop them completely. This last line is very, very important. This last line, that is, greater the frequency of incident radiation, of incident light, greater is the maximum kinetic energy of the photoelectrons. That is, we need greater retarding greater retarding potential to stop them completely. So see how they have proved this, that the minimum cutoff frequency below which there is no photoelectric emission. So I want to tell you that in your textbook everything has been proved very in a systematic manner. So I suggest you that you follow the main textbook. I do not know why the students are away from this textbook. So see this statement, how they have systematically and they have proved it. So I suggest you all that follow the textbook. You will get all the beauty of the science. You will get the beauty of the science, the meaning of science. Then only you will feel some interest in science. Do not go for in a mechanical way. If you go in a mechanical way, you will find no interest in the physics. It will be a burden for you. You are just doing it only to get a seat in a competition. That does not matter what you do. But what I actually want to tell you, that if you go through this textbook, you will learn the beauty of the science. You will feel interest in science. This is all about for today.